afternoon, students. My name is Jacob Okanga. Today we want to discuss a subtopic in moles called molecular formula. So this is not the first time you come across the word molecular formula. It is a common. So in this subtopic, we will discuss about how we can define the molecular formula. So molecular formula is the actual number of atoms. Is the actual number of atoms of various elements present in a molecule. The actual number of atoms. The actual number of atoms in an element. The actual number of atoms in various elements present in a molecule is what we call the molecular formula. Like for example, when you write the word, the formula of methane. This carbon is an atom, hydrogen is an atom, and this one we call it a molecule. So the actual number. So how many number of carbons are here? It is 1. How many hydrogens are here? It is 4. So the actual number, this is the molecular formula of methane. The molecular formula of methane. That is now the actual number of atoms in various elements in a molecule. So we normally have examples under this. First of all, under this molecular formula, we normally have what we call the empirical formula. So the empirical formula is just a simplified way of a molecular formula, or you can just talk of the molecular formula of a compound is a factor of the empirical formula. So we normally calculate the empirical formula before we find the molecular formula. Like in this case here, when you want to find the molecular formula, like for example the methane, you calculate the empirical formula, then you equate to a number n. That n is what you call the actual number of atoms in that molecule. For example, a compound contains 80% carbon. So we have 80% carbon. And the rest is hydrogen. If the relative molecular mass is 30%, work out the molecular formula. So a compound contains 80% carbon and the rest is hydrogen. So it means that hydrogen is what? 20%. So if it is 80%, hydrogen will be 20%. That is now the rest. That is hydrogen. So first of all, you can get the empirical formula. So you start by writing the element composed in that compound. We have carbon and hydrogen. Then after writing the element, you normally have what we call the percentage composition. The percentage composition, you can equate it with the atom, the percentage composition or the molecular mass. You can talk of the molecular mass or the molecular weight. So you have carbon 80%, then you have hydrogen 20%. Then we normally have the relative formula mass of carbon, RFM of carbon. So number 3 have the RFM, relative formula mass of carbon, which is 12, hydrogen, that is 1. Remember, it is only 1 hydrogen. The molecular mass of hydrogen is 1. Then we go to the number of moles. The number of moles. So moles, you take the percentage composition divided by the relative molecular mass. How you can calculate the moles? You normally take the mass over the relative formula mass, and this mass is equated to percentage or mass. So when you take 80 divided by 12, you get the number of moles. Then when you take 20 divided by 1, you get the number of moles. The mole. Then you normally have the mole ratio. For the mole ratio, you divide this number of moles by the lowest number possible. Like for example, here is 20. So here I don't. Here is what? Let us use a calculator. 80 divided by 12. 80 divided by 12. you find it is 6.67. So when you divide by 6.67 by 6.67, you'll get the number of moles. So here is 1:2. 20 divided by that, you get 3. So that is now what we call the mole ratio. The mole ratio is divided by the lowest number possible. Now, so this compound, this molecule is carbon and hydrogen, but on the hydrogen side you have what we call 3. So that is now the empirical formula of that molecule. Now, when you want to calculate the molecular formula of that molecule, carbon is number 12. So the relative molecular mass of carbon is 12. Then you add, you find the summation of its individual relative molecular weight. Hydrogen is 1, but here you see 3 atoms. So it is 1 times that is 3. Then this one equal to N, which is equals to, have we been given the molecular weight or the so you have been given the RMM, that is the relative molecular mass, as 30, so equated to 30. Then so that is 15N is equals to 30 by 15 by 15. So N is equals to 2. So here is N, so it means that when you multiply both sides in the bracket by 2, we'll get that this is Cn and this one is C2 and the H6. So this one is the ethene. Not ethene but ethane. That is now the molecular formula of ethane. Thank you for watching. We shall meet in the next class.